In the previous video lesson, we studied about electric field due to an infinite plane sheet of charge. This video lesson is an extension of that only. Here we will study electric field due to two infinite plane sheet of charge. So these are the two infinite plane sheet of charge having certain charge densities. Here we will study case number 1, similar charge densities. Similar charge densities means these two sheets are charged with positive charge densities or negative charge densities. Let us take positive charge density. The first sheet A is charged with charge density sigma 1. Second sheet B is charged with charge density sigma 2. So these charge densities or this sheet create an electric field in this region 1, electric field in this region 2, as well as electric field in this region 3. So electric field created due to first sheet is given by EA is equal to sigma 1 by 2 epsilon 0. Similarly, electric field created due to second sheet is given by EB is equal to sigma 2 by 2 epsilon 0. So the direction of electric field due to first sheet in this region is like this, and in this region 2 is like this, and in this region 3 is like this. So the electric field in the region 1, 2 and 3 due to first sheet is like this, and like this. Similarly, second sheet also create an electric field. In this region, electric field due to second sheet B is like this. In this region it will be radially away, and in this region also it will be radially away. So EB is the electric field due to second sheet only. Now look at the region 1. Region 1, you can see the electric field EA and EB are at the same direction. Therefore, according to superposition principle, they get added up. So the net electric field in the region E is equal to EA plus EB. What is EA? Sigma 1 by 2 epsilon 0. What is EB? Sigma 2 by 2 epsilon 0. Therefore, it will be sigma 1 by 2 epsilon 0 plus sigma 2 by 2 epsilon 0. 1 by 2 epsilon 0 can be taken out into sigma 1 plus sigma 2. So that will be the net electric field in the region 1, and the direction of that electric field will be in the direction minus I, because electric field is always a vector quantity. So that means it is towards the negative x direction. Now let us consider region 3. There also you can see the arrows electric field are in the same direction. So that means the net electric field will be EA plus EB. Electric field due to first charge EA sigma 1 by 2 epsilon 0, second sheet EB sigma 2 by 2 epsilon 0. Therefore, let us add them together. Sigma 1 by 2 epsilon 0 plus sigma 2 by 2 epsilon 0 is equal to 1 by 2 epsilon 0 times sigma 1 plus sigma 2. What will be the direction of net electric field? Since EA and EB both are in the same direction, net electric field will be in the positive x direction, that is I direction. So electric field is a vector quantity, therefore it is better to represent electric field always in vector form. Now let us consider electric field in the region 3. You can see in the region 3, EA and EB are not in the same direction. They are opposite to each other. Which one is bigger? That depends upon the charge density. Is sigma 1 greater than sigma 2, EA bigger than EB, therefore net electric field will be EA minus EB. That will be 1 by 2 epsilon 0 times sigma 1 minus sigma 2. The net electric field will be in the direction of EA, that will be I direction if EA greater than EB. Similarly, the second possibility is sigma 2 greater than sigma 1. Then EB will be greater than EA. Then the net electric field will be 1 by 2 epsilon 0 times sigma 2 minus sigma 1. Since sigma 2 greater than sigma 1, it will be in the negative I direction, negative x direction. So these are the different regions and the net electric field if two sheets are charged with the charge density sigma 1 and sigma 2, and also these charge densities are similar. Now a special case I can tell you, if sigma 1 is equal to sigma 2 is equal to sigma. What's the meaning of that? These two sheets are charged with the similar charge density, as well as their values are same. Sigma 1 is equal to sigma 2 is equal to sigma. So if the values of the charge density also same, Then in region 1 and 3, what will be the net electric field? We already studied region 1 and 3. The net electric field is 1 by 2 epsilon 0 sigma 1 plus sigma 2. So since sigma 1 is equal to sigma 2, I can write 1 by 2 epsilon 0 into sigma plus sigma. Sigma plus sigma will be 2 sigma divided by 2 epsilon 0. 2 and 2 cancels. Electric field E is equal to sigma by epsilon 0. And if the charge densities are same in the region 2, where is the region 2? This is the region 2. I can show you this is the region 2. And what is electric field in the region 2? Electric field in the region 2 is 1 by 2 epsilon 0 times sigma 2 minus sigma 1 if sigma 2 greater than sigma 1. Sigma 1 minus sigma 2 is sigma 1 greater than sigma 2. Here, none of them are greater. Sigma 1 is equal to sigma 2. Therefore, the net electric field will be 1 by 2 epsilon 0 into sigma minus sigma, that will be 0. So that means net electric field in this region in between the two sheets of charge is 0 only if these sheets are charged with the same charges and also the charge densities are same. Let us consider another case, dissimilar charges case. So you can see the figure, dissimilar charges means first sheet is charged with positive charge, second sheet is charged with negative charge. Charge density of first sheet is sigma 1, charge density of second sheet is sigma 2. So the positive charge creates an electric field, its direction will be radially outwards. In all the region, its direction will be radially outwards. But look at the negative charge distribution. It creates an electric field that is radially inwards. In all the region, it is radially inwards. Therefore, look at region 1, region 2 and region 3. Electric field due to sheet A and B are opposite to each other in region 1 and region 3, but they are in the same direction in region 2. Now, we already studied electric field. If they are opposite, the net electric field will be bigger field minus smaller field. Let us consider region 1. If sigma 1 is greater than sigma 2, electric field due to sigma 1, that means EA, will be greater than that of EB. EB is the electric field due to sigma 2. So if sigma 1 is greater than sigma 2, then the net electric field will be 1 by 2 epsilon 0 times sigma 1 minus sigma 2. So the direction will be in the direction of EA, that will be the negative I direction. Similarly, on other hand, if EB is greater than EA, that is possible only if sigma 2 greater than sigma 1, then electric field due to negative charge distribution EB greater than EA, then what will be the net electric field? E is equal to 1 by 2 epsilon 0 times sigma 2 minus sigma 1. The direction will be in the direction of bigger field, that is I. Now let us consider region 3. In region 3, E is equal to EA minus EB if sigma 1 greater than sigma 2. Sigma 1 greater than sigma 2 means EA greater than EB. Then the net electric field will be EA minus EB. That will be 1 by 2 epsilon 0 times sigma 1 minus sigma 2. The direction of that electric field will be in the direction of bigger field, that will be I. Whenever I am multiplying with the unit vector I, it should be represented by a vector sign. Now, in the region 3, if sigma 2 greater than sigma 1, where is sigma 2? This is sigma 2. If sigma 2 greater than sigma 1, obviously EB greater than EA, then EB minus EA will be the net electric field. EB minus EA, that will be 1 by 2 epsilon 0 times sigma 2 minus sigma 1. And the direction will be in the direction of B, electric field due to B, EB, and that will be minus I direction. Now look at the middle region. Middle region, the arrow indicates that electric field due to plus charge and minus charge, EA and EB are in the same direction. Therefore, the net electric field E is equal to EA plus EB. E is equal to 1 by 2 epsilon 0 times sigma 1 plus sigma 2. The direction of the net electric field will be in the direction of I. So these are the three different regions and electric field due to these charged plates in this region. Net electric field also we studied. Now I am going to discuss a special cases. A special case in which sigma 1 is equal to sigma 2 is equal to sigma. In the region 1 and 3, since electric field is 1 by 2 epsilon 0 into sigma 1 minus sigma 2 or sigma 2 minus sigma 1, if sigma 1 and sigma 2 are same, then electric field is equal to 1 by 2 epsilon 0 into sigma minus sigma, that will be 0. But in the region 2, look at region 2, electric field are in the same direction. Therefore, net electric field we already studied 1 by 2 epsilon 0 times sigma 1 plus sigma 2. If sigma 1 is equal to sigma 2, then 1 by 2 epsilon 0 times sigma plus sigma. That means 1 by 2 epsilon 0 times 2 sigma. 2 and 2 cancel. Therefore, electric field is equal to sigma by 2 epsilon 0. So the region in between two equally and oppositely charged infinite plates. The region in between two equally and oppositely charged plates, electric field E is given by sigma by epsilon 0, where sigma is the charge densities of magnitude of the charge densities of either plates.